Hello, hello, hello. Welcome, welcome, welcome. Happy Tuesday. Welcome back to Math on YouTube. It's Mr. Taco here. Thank you all for being here. I hope you had a good 3-day weekend, if you had a 3-day weekend. If you didn't, then I hope you're having a really good Tuesday. Great. Okay, whole number times decimal part 2. We're going to go a decimal place further and take a look at the hundredths place today. You're going to need something to write on, something to write with, the usual stees. And then down here, I can explain how fractions and decimals can show equivalent values. And I can use an area model to multiply a whole number by a whole number plus some hundredths. So let's get started on that. Again, disclaimer, don't let the decimal point scare you. Okay? This is, in essence, a 3-digit by 1-digit multiplication problem, which we've done ad nauseum last year. Okay? So the short answer for this is just like last week when we talked about breaking up our whole number and our decimal into partial products, we can do that here, right? Just like, if this were 234 times 5, we wouldn't bat an eye at it. We'd just go, oh yeah, you do 200 times 5 plus 30 times 5 plus 4 times 5, and then you add them all up at the end, right? The fact that there's a decimal point here doesn't change anything about our process and our setup. We're still going to divide this out into 3 partial products or partial factors and multiply each one by 5. So set it up here, our big rectangle. Since we have 1, 2, 3 partial products, or partial, or 3 digits here in our 2 and 34 hundredths, that's how we're going to split it up. 2, 3 in the tenths place, and then 4 hundredths. And do make sure to put that 0 in the tenths place here, right? Because we've separated this out. 4 hundredths plus 3 tenths equals 34 hundredths total. And we're going to do each piece multiplied by 5, right? 5 times 2 is 10. 3 tenths times 5. Okay, thinking about, how many tenths? We're doing 3 tenths times 5. 3 tenths, 3 tenths, 6 tenths, 9 tenths, 12 tenths, 15 tenths. 15, and then our smallest place is the tenths place. So we end up with 1 and 5 tenths, which makes sense, right? If we have 15 tenths, we can take 10 of those tenths and make 1 whole. Okay? Then 4 hundredths times 5, right? 4 hundredths times 5. So I'm going to put up my 5 groups again. Each one of these is going to be 4 hundredths. 4 hundredths, 8 hundredths, 12 hundredths, 16 hundredths, 20 hundredths. 20, and then there's the hundredths place, so there's the tenths place, so there's our decimal point. Okay, 20 hundredths. Alternatively, we can certainly, because there is a 0 in the hundredths place with nothing to the right of it, we don't actually need that, so we can write it as an equivalent decimal of 2 tenths. Now, let's add them up. 10 plus 1 and 5 tenths. Do make sure, and I like to put my 0 in the tenths place there, just to make sure. Hold on, pause. Hello. Excuse me. Heck of a sneeze there. 10 and 0 tenths, 1 and 5 tenths. And then 2 tenths. And you can put a 0 in the ones place to remind you that there is no whole number there. It's just some tenths. Then add them straight down and keep your decimal point right where it is, in between the ones and the tenths. 5 tenths plus 2 tenths is 7 tenths. 0 plus 1 plus 0 is 1, and then 1/10, bring it down. So we end up with a final product of 11 and 7 tenths. Okay, we're going to practice more of these as we go, but again, the big thing here is just treat these like they were any other digit in place value, right? Left side of the decimal point, right side of the decimal point. It still follows the same concept. 10 of one thing equals 1 of the next group over. right? One group, you can go one place to the right and divide that into 10 equal pieces. Now let's talk about, on that vein here, let's talk about a little shortcut, okay? I'm going to scoot in a little bit. There we go. Again, reminding ourselves that when you move one place to the right, when you move one place to the left, you're essentially multiplying by 10. If I take this, 6 in the ones place, and I move it there's my decimal point there. Now it's become a 6 in the tens place, and 6 tens, right? 6 times 10. Likewise, when we move one place to the right, we're dividing by 10. So if I take those 6 tens, divide it by 10, now it's become 6 ones. I take those 6 ones, divide it by 10, now it's become 6 tenths, right? Divide those 6 tenths by 10, now they become 6 hundredths. Okay, so as we use this rule of 10, we can actually shift our number and our values as we go, multiplying or dividing by 10 every time we move one place to the left or to the right. The other thing we want to think about here that we're going to need for this shortcut is this idea of inverse operations. Inverse kind of meaning mathematical for opposite, right? So let's think about this. Let's think about 7 plus 10 minus 10. Okay? 7 plus 10 is 17. 17 minus 10 is 7. Right? These are inverse operations, addition and subtraction. So if you add an amount to a number and then you subtract that same amount, essentially what you've done is you've canceled out what you just did and you end up right back at the start. Okay? This is also true for multiplication. 7 times 10 with the inverse operation of division. So if you do 7 times 10 divided by 10, you're still going to come up with 7, right? 7 times 10 is 70. 70 divided by 10, well, it's back to 7, right? This is very, very useful when you're dealing with decimals. Because let's say we had, and you know what, I'm not going to use, where did my little blocker go? We're not going to, darn it, I cut one. I'll cut another one. We're not going to use this whole 6-digit thing right at first. I'm just going to cut a piece of paper to block part of this demo number here. There we go. And it's going to look like, let's just use 12. Okay? So here we have the number 12. Okay? 12 ones or 1 10 and 2 ones. All right, I'll even scoot in a little bit more, tilt it up so you can see. Okay? The nice thing about inverse operations is if we have something like 12, we're going to divide it by 10. Meaning, we're going to take this decimal point, we're going to take everything and shift it one place to the right. It almost looks like the decimal point's moving to the left. Right? 12 divided by 10 equals 12 tenths, or 1 2 tenths. Okay? Zoop. There we go. And then let's say I do 1 2 tenths times 10. 1 2 tenths. And again, because I'm multiplying by 10, I'm moving my number to the left. It looks like my decimal's going to the right. And then I'm back at 12. Okay, this can be particularly helpful when dealing with decimals, because what you can do is you can take your decimal number and you can use our rule of 10 to kind of make that a whole number right at the beginning. And then, as long as you do the inverse, the opposite of what you did, essentially undoing what you did, at the end, you'll have an accurate result. Let me show you what I mean. So let's say we have, I'm going to use, let's go, I need one more digit here. There we go. Let's go with 1 and 23 hundredths times, we'll keep it simple, we'll times 2. Okay, 1 and 23 hundredths times 2. Now, what I'm going to do here is, before I do anything else, I'm going to use my place value rules here, and I'm going to essentially, I'm going to hide that decimal point, okay? And I'm going to do that by going, okay, I need to move, in order to hide the decimal point and make this a whole number, I have to go 2 places larger. So I essentially did times 10 times 10, or times 100. So essentially what I've done is I've changed this into 123 times 2. Now, that's going to give you a very different answer if you don't remember to undo it at the end. So I'm going to make a little note for myself. I'm going to say 2 places larger. Or I might say I might go times 100. Okay? Because at the end, what I'm going to do is I'm going to do the inverse of this, which is to divide by 100. Okay? So I do 123 times 2. I'll use standard algorithm for this. 3 times 2 is 6. 2 times 2 is 4. 2 times 1 is 2. Okay. Now remember, this is our original answer, our original problem. 1 and 23 hundredths times 2. Would it make sense if 1 and some change times 2 equaled 246? No, because we've got to undo what we did. We have to take this, and remember our decimal point is here. Because we moved 2 spaces larger at the beginning to hide our decimal point, we're going to move 2 spaces smaller. So we're going to take this decimal point and we're going to go zoop, zoop, and it's going to end up right there at 2 and 46 hundredths. Okay, so that's a little shortcut if it's challenging or if it's kind of more work for your brain to multiply all these partial product decimals. Okay, what you can do is you can say, okay, how many places do I need to move my decimal point to hide it and essentially make the whole quantity a whole number? Then I'm going to move that many places back at the end to make sure I'm using an inverse operation and I'm kind of canceling out what I did at the beginning. And then I will be left with my accurate answer. Let's try a couple on the digital whiteboard. First one here, 6 times 3 and 27 hundredths. First we're going to do it with the area model, and then we'll do it with our shortcut. So 3 partial products, put our 1 digit on the side, then we have 3, we have 2 tenths, and then we have 7 hundredths. And do make sure they're in hundredths. Okay? I'm willing to bet I will see at least one of these on the exit ticket where somebody goes, oh yeah, 0.2 and then 0.7. Right? Now you're multiplying 3 and 9 tenths times 6, which is much different than 3 and 27 hundredths. You've got to have this 0 in the tenths place here. Okay, so now let's try it. 6 times 3 is 18. 6 times 2 tenths Or, right, we can use our shortcut here. We've got to move the decimal one place to the right. So I'm going to make a little note for myself. 1 right. Okay. 6 times 2 is 12. And to undo this shortcut, I got to move 1 back to the left. Zoop. To make 1 and 2 tenths. Okay, that's a little hard to read, so I'm going to rewrite it. There we go. And then here, 6 times 7. I should have made the boxes bigger. 6 times 7 hundredths. Okay, alternately, you can say, okay, I'm going to hide this decimal by moving 2 places to the right. So I'm going to remember 2 to the right. 6 times 7 is 42. And then I'm going to move 2 to the left to undo my inverse. And I'm left with 42 hundredths. Then add them together. For a total of 19 and 62 hundredths. And do check for reasonableness here. Take a look back at our original problem. 6 times 3 and 27 hundredths. So thinking about, okay, 6 times something a little bit more than 3. Would that make sense that equals a little bit more than 19? Sure, that seems reasonable, right? Because 6 times 3 is 18. So it stands to reason that our answer would be a little bit more than 18, which 19 and 62 hundredths is. Now let's check it using our shortcut. For your standard algorithm fuddy-dudds, this might be easier. So we have 6 times, whoops, I'll use the x here. 6 times 3 and 27 hundredths. Okay, in order to get this this multiplication equation into whole numbers, so we can think about it easier, we've got to move 2 places. We've got to move our decimal point 2 places to the right, or essentially moving our number 2 places to the left. So I'm going to make a note for myself, 2R for 2 right, or 2, I could put 2 greater, 2 places greater. I could do times 100, essentially what we're doing here. So then we're going to do 327 times 6, and then what we'll do, we'll divide by 100 at the end by moving our decimal point 2 places to the left. So 7 times 6 is 42. 2 times 6 is 12, plus those 4 tens equals 16 tens. And then 6 times 3 is 18, plus that 100 is 19 hundredths. Then at the end, now we've got to take our decimal point. We're going to move it 2 places, 1, 2, to divide by 100, to get rid of that multiplication that we did. And lo and behold, 19 and 62 hundredths. Same deal there. Fascinating. Let's try one on our own. And I'm actually going to step back on this one. We're going to go back to just tenths on this one because I want us to kind of practice in both ways. So let's go with 8 and 6 tenths times 4. First, think about reasonableness, right? 8 and 6 tenths is between what 2 whole numbers? So where is our answer going to be? What range is our answer going to be between? Right? 4 times 8 is 32. What's the next whole number up? 4 times 9 is 36. So our final answer is going to be somewhere in between 32 and 36. How many places do you need to move that decimal point to hide it? And then remember to bring it back that many places at the end if you're using the shortcut. Giving you some time to work on it, looking for answers in the chat. You'll need 2 partial products for this one. Give it a go. While we're doing that, just a reminder to those of you still using multiplication tables, okay, using a multiplication chart for your facts, great. Okay, it's a great tool to use. The more we can get automatic with our facts, the kind of less work it becomes and the fewer steps it becomes. But again, multiplication chart is a great resource, right? It's not cheating to use a multiplication chart. It's really not. When we're doing something like this where there's lots of different multiplication equations going on and lots of different partial products, using a multiplication chart is just as good as doing it automatically, right? What we don't want is to not have it automatic, but also not use the chart. So now you're having to like prove every single partial product, and that can take a long time. And that can be pretty time consuming and pretty intensive, okay? It can be a lot of work that goes into that. All right, we're positing in the chat, we're seeing 34 and 4/10 with a question mark. We're not sure about it, so let's check it, okay? 8 times 4 equals 32. 6/10 times 4. 6 times 4 equals 24. And then we'll put the decimal point back one place for 2 and 4/10. And then we add them. 32 plus 2 and 4/10. 32 plus 2 is 34, and then we have our extra 4/10. So there we go, 34.4, as it were, or 34 and 4/10. Alternately, you can do it this way. 8 and 6/10 times 4. Okay, we're going to multiply by 10 up here, so moving one place to the right to hide our decimal point. Okay, so we've gone 1 to the right. We need to put 1 back to the left once we're done. 6 times 4 is 24. 8 times 4 is 32, plus 2 is 34. And then we've got to make our inverse here, so our decimal point's there. We'll move it one place back to the left, or move our number one place to the right. And we're left with the same final answer. Okay, so again, 2 different methods to solve decimal multiplication. Area model works great. Okay, shortcut method, where we're kind of using multiplication to hide our decimal point. We're not getting rid of it, we're hiding it. Using multiplication to hide our decimal point, and then using division at the end to put it back, to undo what we did at the beginning. They both work. Remember, the key here, check for reasonableness. Okay, I will see at least one answer that is like 4 and something times 6 equals 250. Or 4 and something times 6 equals 2 and 4/100ths. How'd that work, right? So using that reasonableness and estimation to go, okay, my answer is going to be around here. And often what you can do is you can just kind of, if you use your estimation, you can just kind of know where your decimal point is supposed to be. Like on this one, even if I didn't know how many places I was supposed to put it back, because I used reasonableness and went, okay, I know my answer is supposed to be between 8 times 4, which is 32, and 9 times 4, which is 36. So where can I put the decimal point that makes that number? Well, I can put it right here because it's 34.4, right? So good luck on the exit ticket. Come to office hour if you want more practice or you have more questions, and then do that exit ticket, and then have a good lunch, and we will see you, tacos, we'll see you for journal.